Hello and welcome to another video. In this one, I'm going to go over my approach to tackling programming interviews. Now, for better or worse, the industry continues to use algorithms interviews as a way to test candidates, despite, in my opinion, they're not necessarily a good representation of how an engineer actually would work in the day-to-day, but alas, they're still used, so you still gotta be good at them. So I'm going to show you my approach to tackling these and kind of a framework that you can use to approach these as well. So anyway, let's jump into that. Okay, and again, I've talked a little bit about this in some other videos, for instance, like what programming language you should use. I'll try and remember to link those in the description as well. But let's get started with a programming interview. The typical way that they will go is they will start with the interviewer introducing themselves, and you'll give a short introduction. Make sure to make it a short introduction because the focus of this is programming, and you want to give yourself as much time to solve the problem as possible. And so you'll do your short intro. Then usually the interviewer will hand you a question. In this case, I have prepared a question that I used to ask at Yelp and is a popular what's it called, LeetCode problem. Although back when I asked the question, LeetCode didn't even exist. So I'm not saying I invented the question, but it's a very common paradigm, and so not that surprising. But anyway, they will hand you a question and you'll get started. Now, usually for these, you'll have some sort of interactive programming environment, things like CoderPad or Visual Studio Code has a share screen thing, but basically you'll open up whatever your environment is here. I'm just going to be using the terminal because I don't have CoderPad open. We're going to be just writing our code in a little t.py file. Now, the first thing that you're going to want to do is read the question. Of course. So we're going to do that really quickly. So we're going to be implementing a problem called combined business hours. It's going to take in hours, which is a list of two integer tuples, and return a new value here. Usually when I see something like this, my brain is ticking, okay, we're going to receive some value and return a new value. And usually when you're implementing functions that take a value and return a value, you won't be modifying the input. And so that's kind of what I'm thinking about when I'm seeing this signature here. And then we'll read the rest of the text. Yelp displays business hours on the web page. The data is sourced from several locations. Some comes from user-submitted data, and other data is purchased and imported from third-party providers. This data is of varying quality, so Yelp needs to massage this data to make sure it is presentable to users. This interview question is about one stage of sanitizing the data, combining adjacent ranges. Our data will be represented as a list of two tuples representing the open and close times, and here is an example where 1, 2, 2, 3, 5, 6 becomes 1, 3, 5, 6. In this case, these two pieces got combined. Okay, so once you've read the question, the next step that I usually approach is if there's anything that I need to ask questions about this, like maybe there's some part of this question that's unclear that I need to ask the interviewer, so I will ask any clarifying questions. In this case, I don't think that there's anything super clarifying that I would need to ask here. I might, I noticed that thing and made a mental note about, not modifying the input here. I might, state any assertions here, state any assertions. So this could be saying them as statements, but are questions. So I might say like, hey, I noticed this takes hours as inputs and also returns hours back. I'm assuming that it is not being modified. So this is a place to demonstrate some knowledge, but also ask questions and get clarifications at the same time. So that might be something that I would state about this question. I think beyond that, it's fairly straightforward what's being asked here. The next thing that I would do after stating any assertions is I would talk about my general thought process for how to solve this problem. Speak through a general thought process. And usually what I'm looking for here when I'm doing this is to talk about what needs to be done, and also if you can get any early ideas about what the performance will be. Now I've done this problem many times, so I know the exact answer to this. But when I'm approaching this, I might say, okay, well, if I'm combining adjacent hours, this means I need to look at least each element at least once. So I know the bare minimum for this has to be at least linear time. And the way I'm probably going to approach this is I'm going to look at an element and then look at the next element after it, and if they have the same closing and opening time, then I know that I can combine them. And I can continue to work through the list and do all of that. And that's how I'll approach this problem, and we'll translate that into code afterwards. And with that algorithm, I'm thinking, the minimum is linear. I think I can also accomplish what I had just said in linear time. So that's probably what I would do from speaking through a general thought process there. Then after this, I like to switch into a test-driven development mode. Now, test-driven development isn't, generically applicable to all software development, but it does show kind of a positive thing in an interview state. You generate some set of test cases before you even start writing the code to show that you understand the problem and then you know what you're trying to aim towards. So I will be a TDD, write up some test cases. And what I would recommend here is use whatever testing library is appropriate for your language. Use whatever testing library for your language. In my case, I'm using Python, so I'm going to use PyTest if it's available. If it's not available, I would fall back to like unit test or whatever the built-in testing framework is. But I'm going to try and use whatever framework I know. If you're working in, Ruby, you would use like RSpec or whatever. But yeah, you're gonna write actual tests in whatever your testing library is for that language. And this gives you some time to look around at edge cases for stuff. So let's actually do that for real. On CoderPad and in most programming environments, you're only going to have a single file. So unfortunately, you're going to write your actual code and your testing code in the same file. Normally, you would separate those out. But in our case, we can do if name equals main, and then raise system exit pytest.main _ file. This is how you can run PyTest directly in your code. Import PyTest, and we're gonna take this and write our actual function here, and then list tuple int int, and list tuple int int. Dang it. So I would make this an alias, but whatever. I'll actually shorten this function because it's going to be really annoying to type this over and over. And you can, say stuff like that in the interview. Like normally I would spell this out as combined business hours, but since we're going to, we're pressed for time, I'm going to shorten this to CBH. You of course don't have to do that. That's just me being lazy here. So we're going to, just for the sake of TDD, we're going to implement just a very basic case. We know this is wrong, but now we're going to write our test cases. Test CBH and input hours and expected. We have kind of a nice input and output, so it's very easy for us to do pytest.mark.parameterize, and then input hours and expected. And here's where we are going to write our test cases. We're going to do assert CBH input hours is equal to expected. I might also make an example or an assertion based on the thing that I mentioned earlier, where we say, okay, we're not going to mutate our input. So we might add another test. Test does not mutate input. And we'll specifically write out maybe the example case that they gave us, 2, 3, 5, 6, and then assert CBH list equal to 1, 3, 5, 6, and then we want to assert that we didn't make any modifications. This is again writing out our assertion from earlier. And now we write some of our input and output test cases. Now, when you're looking for input and output test cases, you kind of want to start looking for edge cases. And you also want to tell the interviewer that that's what you're doing. So you want to always be talking about what code you're writing, and continue to educate them on what you're thinking inside of your head, because they don't know what you're thinking unless you tell them. And so in this problem, and a lot of problems that deal with lists, a good start of edge cases is to look at empty values, n equals 1 values, and then any domain specific things there. So I'm going to start with the empty list. That's a very easy input and output. The empty list should return the empty list. Another edge case here might be an item or list where there's only one item, and of course that should also output the same thing there. I always recommend grabbing whatever example case they give you. So in this case, you have this. And then you'll want to write some more test cases yourself. The other thing about writing these test cases up front is you don't necessarily have to find all the edge cases as you do this. You may find more edge cases as the problem goes on. So even if you just have, you know, these to start with, this is a fairly good set of examples here. Now you would probably also want to have one where, you know, you don't combine anything at all. So you might have like 1, 3, and then 5, 6. And that should be the same input and output. One of the tricky parts of this problem that isn't stated up front, but may be something that you discover along the way, is combining multiple inputs. So you might have like 1, 2, 2, 3, 3, 4. And that should be combined all the way down to just 1, 4. But yeah, there's a whole bunch of other edge cases I mean, there aren't a whole bunch of other edge cases, but there's a whole bunch of other potential test cases that you could write here. But let's say that these are the ones that I came up with to begin with. Should also write some more notes for our little framework here. Come up with edge cases. Don't worry about finding all of them up front. You may add to this later. Okay, once you've done that, it's usually a good idea to run your tests and demonstrate that they fail. This is the first step of TDD. So actually install PyTest. So we'll run this and assert that we have some test failures. PyTest t.py. And some V's here. Oh, right, from future import annotations, or if you're using, I used Python 3.9 syntax here, so that's why it's mad about that. Cool, so you can see that we have at least 3 test failures, and that's because we haven't implemented anything at all. So you can see in the does not mutate input, we might actually be able to just remove the assertion here. That way we actually show that this is passing, because this was actually testing 2 things at once, but now it's only testing 1. Okay, cool. So now we just have failures where we're combining things. So this test is failing and this test is failing. And so then we get into the actual implementation of our code. And this is the part where I can't really help you. you kind of just have to be good about algorithms and thinking through processes, knowing your data structures, knowing, like, you know, being comfortable writing in whatever programming language, and that sort of thing. Actually implement the thing. And you know, the implementation for this particular problem isn't that interesting. I will show you how I would implement it. We'll have a return list, and actually we can start by having our edge cases out of the way. So if len of ours is less than 1, less than or equal to 1, we know that in this case we can always just return a copy of the input. And again, we want to return a copy here, and this is something that you would communicate. We want to return a copy because we're treating the input as immutable, and we would give a new value in that case. So this satisfies our 2 test cases here, gets those kind of out of the way for us. And you know, whenever you implement something, I would go back and start you know, running our test cases and making sure that we have things satisfied. Again, like, we don't, because we're just returning empty list here, but we do satisfy our 0 and 1 test cases here, so we are going further here. And actually, if we were doing true TDD, we would probably start by return none, so that way the first time we ran this, we would have all of our test cases failing, and then we would start by trying to make this one pass by doing return empty list. So that would get us 1 test case passing, and then we would go to try and solve this test case, and we would implement this piece of minimal code to get our 2nd test case passing. And then we go on to our 3rd one where we need to combine things, and that's where you would do the actual implementation. Okay, cool. So the way that I actually solve this is by doing ours 0, and then for start and in, hours 1 colon. So I'm actually going to compare backwards. So the way my approach to this is going to work is I'm going to look at this one and compare the previous value and then modify the previous value if they're the same. That way we can handle multiple runs here. And so we'll say if ret -1 1, so this represents the end hour of the previous thing, is equal to start, then we do ret -1 equals ret -1 0 and end. So this is the combining case. Otherwise we just append ret dot append or end. And of course, like, you know, I've seen this problem hundreds, probably almost thousands of times at this point, so I know the answer very, very quickly. But, you know, it's okay to struggle through problems and work through them and debug them and do all sorts of stuff there. Like, the expectation in a programming interview isn't that you just know the answer immediately. So it's completely fine to spend time debugging stuff around and playing with stuff. And I encourage you to know the debugger of your language and be able to, you know, set breakpoints and debug those on the fly. So you would be able to, you know, look at your return value and play around with, you know, your values here and use your debugger. Because, you know, most of the time you're not going to get it right immediately. Cool. So assuming you get to actually implementing the thing, and again, like my strategy for actually implementing the thing, this is a thing that I struggle with a lot. There are kind of 3 priorities to making a successful interview solution. And the absolute first thing that you should be aiming for, so number 1, this is the most important, is make it work at all. And so this is like getting the successful inputs and outputs. This is absolutely the most important thing about implementing your interview solution. After that, the second priority is making it performant. So this is like optimizing it to the, you know, optimal solution. Now, granted, mine is the optimal. Well, there's actually a slight improvement that can be done here. And so your second goal is to make it as performant as possible, and that's to satisfy any algorithmic, you know, performance bounds that you would want to do there. And then the third, and again, this is less important, so maybe not that, make the code clean. And in some cases, these two can be flipped. Like, I guess I don't want to say clean, let's say readable. And, you know, these 2 priorities can kind of go back and forth depending on what you're trying to aim for here. So like, yeah, you can have the ugliest code possible, but making it work is the most important thing. And that's, you know, that's like 50% of what your interview counts for. So making a successful solution is very, very important. And like, I wouldn't worry so much about performance, and, you know, readability can come later. Like one solution to this problem that I've seen is a double nested loop where they're looping over the hours, and then there's an inner loop where it looks as far forward as it needs to. And yeah, that has a double loop, and it's, you know, not as clean as just a single loop here. But it does solve the problem. That's the first and absolutely the most important part of your interview. Next, after that, once you have something working, even if it's not the most performant, like as soon as you get to it working, you're going to want to talk about how it performs. Algorithmic performance. And so you'll want to walk through each part of your code and talk about how it works in Big O notation. And so looking at my problem here, you know, this is O1 because len just accesses the length. This is a copy, so we know that this is linear time, but since it's always either 0 or 1 elements, we can think of this as constant time. So this entire piece here is constant time, so we don't factor that in. This is accessing a single element, so this is constant time as well. This is a loop over each element in our list. So this is algorithmically linear time, so we're doing a linear amount of work here, at least in this loop. We haven't actually looked at the inner parts yet. And sneakily, this is actually a linear amount of space, because a slice of a list does a copy of the whole thing. We could, of course, cheat around this by using itertools.islice hours 1 none, and that would avoid that copy there. So this may be some improvement that you would do as part of, you know, step 2 of this. And one thing that I always talk about in interviews, and this is like kind of just a demonstrate knowledge situation, like, yeah, you may be able to improve the efficiency of this, but this may not actually matter in the scope of things. So whenever I approach performance, I always do profiling before making a reactionary fix there. So it may already be optimal even without this itertools islice here. But yeah, just a little tidbit there. So then I would look inside the loop. This is just list accuracy, so this is constant, equality is constant, assignment is constant, and making this tuple is constant, and appending is amortized constant. It can cause the list to resize, but generally you think about it as being constant time. So anything inside this loop is approximately constant time, and so that means that the runtime of this loop overall is linear. And of course, this is constant. So overall, our runtime is linear. We're going to build up a list, which is at most the same length as our input list. So it's space-time linear. And so overall, this would be linear for runtime and space. And when you talk about algorithmic performance, you also want to kind of tie back into what you originally said before, what you expect the performance to be. So you'll say like, okay, well, we absolutely need to look at every single element. So we at least have to have linear runtime. We achieved linear runtime, so that's optimal. And we know that we're making at least a copy of the full value. So at least we have to do linear space overhead. And so we achieved linear space overhead. So we have our optimal performance. And there's often a trick question that your interviewer is going to ask you. They're tricky sometimes, and they're going to say, how can you do better? And a lot of the times you can't. And so you just need to be able to talk through how you can prove that you can't do better. And after that, that's basically the end of the programming interview. Now, sometimes, and most times, there will be kind of an optional 8th step where there will be a twist to the problem, where the interviewer will add an additional constraint to the problem or change it slightly and watch how you adjust your particular code. The twist that I used to ask on this problem, I used to ask kind of 2 twists depending on how they implemented their code. One of the twists might be that these overlap, so you might see like 1, 3, and 2, 4, where they have ranges that stack on top of each other, and the adjustment to there is just setting a changing equals to greater than or equal to. The other twist that I would ask is like we would split hours at 24-hour bounds, and so I would add an additional constraint that if you find a range that spans over a 24-hour period, that you have to split it at the midnight bound. And so that might be something where you would have to adjust how this works. You might have, in this case, I think you add another loop to split instead of just returning a value. But yeah, the twist is actually not all that different from these first steps here. Like you'll go through these same sets of processes and work out a new solution to that. I usually recommend leaving the original code in place and writing another function that implements the twist, or writing another function that can reuse the original code to implement the twist. That way you kind of show that you're building on top of the code. And if you don't manage to solve the twist, you at least have working code from the original solution, because you're not going to be working with version control here, so you don't have a great way to checkpoint where you're at. Oh, but anyway, that was a lot. This is how I approach programming interviews. Hopefully this helps you understand what processes I go through and gives you some tips about this. And again, like if you're only going to take one thing away from this entire discussion, the most important part of a programming interview is making something work, even if it's ugly and even if it's slow. But anyway, hopefully this was useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one. Button, no.